In lesson 7.6, you will multiply a polynomial by a monomial, and you'll also solve equations involving multiplying upon a polynomial by a monomial. In example 1, we're going to multiply a polynomial by a monomial. It really is just distributive property, but more complex than what you've done in the past. So we're going to start by multiplying everything in the parentheses by negative 3x squared. So the first term, we're going to multiply the negative 3 times 7, and you get negative 21. And then x squared times x squared is a total of 4 x's being multiplied together, so it's x to the 4th. Next, we have a negative 3x squared times a negative 1x. Negative 3 times negative 1 is positive 3, so we're going to say plus 3. And then x squared times x is x to the 3rd power, because that's a total of 3 x's being multiplied together. Remember, the rule for multiplying a power times a power with the same base is to add the exponents. And then the last term in the parentheses, negative 3x squared times 4. We're going to multiply the negative 3 times 4, which is negative 12. And then the x squared is just going to stay x squared because there's no other x's to multiply it by. So right there is what you get when you multiply that polynomial by the monomial. You may want to pause the video and try the next ones on your own. 5a squared times a negative 4a squared. Well, 5 times negative 4 is negative 20. And then a squared times a squared is a to the 4th, since there's a total of 4 a's being multiplied together. 5a squared times a positive 2a. 5 times 2 is positive 10. And then a squared times a, that's going to be a to the 3rd, since there are 3 a's being multiplied together. And then 5a squared times a negative 7. 5 times negative 7 is negative 35. And then a squared. Negative 6d to the 3rd times 3d to the 4th is negative 18 d to the 7th, since there is a total of 7 d's being multiplied together. Now negative 6d to the 3rd times negative 2d to the 3rd. Negative 6 times negative 2 is positive 12. And d to the 3rd times d to the 3rd is d to the 6th. 3 plus 3. Remember, you add the exponents. Negative 6d to the 3rd times negative d. Remember, that's like a negative 1d. So negative 6 times negative 1 is positive 6. And then d to the 3rd times d to the 1st. That's a total of 4 d's being multiplied together, so d to the 4th power. And then negative 6d to the 3rd times positive 9. Negative 6 times 9 is negative 54. D to the 3rd. All right, in example 2, we're just going to do that multiple times and simplify the expression if needed after that. So let's start with this part right here. So 2p times a negative 4p squared. 2 times negative 4 is negative 8. And then p to the 1st times p squared is p to the 3rd power. You're adding those exponents for a total of 3 p's being multiplied together. Now 2p times a positive 5p. 2 times 5 is positive 10. And p times p is p squared. Now let's go ahead and do the second part. Remember, this is not just 5 times everything in here, it's negative 5 times everything in the parentheses. So negative 5 times 2p squared Negative 5 times 2 is negative 10, and then it's going to be p squared since there are no other p's to multiply it by. And then negative 5 times positive 20, and that's going to be a negative 100. Now, we're not quite finished here because we have some like terms. Remember, like terms are terms that have the exact same variable part. So if you look here, we don't have any other p to the third, so we're going to just leave that as negative 8p to the third. However, this positive 10p squared is going to be combined with the negative 10p squared. And if you take positive 10p squared and add to it a negative 10p squared, that's going to end up being 0p squared, so it will disappear. And then we also have a minus 100. So negative 8p to the third minus 100 is the simplified expression. You may want to pause the video and try the next one on your own. 3 times 5x squared is 15x squared. 3 times 2x, positive 2x, is 6x. And then 3 times a negative 4 is negative 12. Now right here in this next piece, this is like negative 1x times everything in parentheses. So negative 1x times 7x squared is going to be a negative 7x to the third power. And then negative 1x times 2x is going to be negative 2 to the x, or negative 2x squared. And then negative 1x times negative 3, that's going to be a positive 3x. All right, let's go ahead and combine like terms. I'm going to start with the x to the third term since that's the one with the highest degree. There are no other x to the third terms, so we're going to go ahead and just write negative 7x to the third. Now I'm going to move on to the x squareds. We have a 15x squared and a negative 2x squared. 15x squared plus a negative 2x squared is 13x squared, so plus 13x squared. Now we'll move on to the x's. We have a positive 6x and a positive 3x. So 6x plus 3x is 9x. And then our constant is by itself already, so minus 12. So negative 7x to the third plus 13x squared plus 9x minus 12 is the simplified expression. Remember, an expression is simplified when there are no like terms to be put together and there are no parentheses. The last thing we're going to do is solve equations with polynomials on both sides. So this right here looks pretty ridiculous. We're going to go ahead and draw our train tracks. And then from there, we're going to go ahead and simplify both sides by getting rid of the parentheses. So 2a times 5a is 10a squared. And then 2a times a negative 2 is negative 4a. Then we're going to move on to this piece. 3a times 2a, that's a positive 3a times 2a, that's 6a squared, positive 6a squared. 3a times positive 6, 3a times 6, that's going to be 18a. And then this plus 8 is outside of the parentheses, so we're just going to move that down here. Now on to the other side. A times 4a is 4a squared. A times 1 is 1a. And then 2a times 6a is 12a squared. And then 2a times a negative 4 is negative 8a. And then the plus 50 we're going to bring down. Now the next thing I would do is probably look for like terms that can be put together to make this a little less crazy. So let's start here with the 10a squared and the positive 6a squared. 10a squared plus 6a squared, you just add the coefficients. 10 plus 6 is 16a squared. And then negative 4a plus 18a. Negative 4a plus 18a is going to be plus 14a. And then bring down this plus 8. On the other side, we have 4a squared and a positive 12a squared. That's 16a squared. Then we have a positive 1a and a negative 8a. 1a plus a negative 8a is negative 7a. And then bring down the plus 50. Now I'm going to start by subtracting this 16a squared from both sides, and then that will disappear. And we are left with then 14a plus 8 equals negative 7a plus 50. Now we still have variables on both sides, so I'd get rid of one of them. I'm going to get rid of this negative 7a by adding 7a. (14a plus 7a), that's going to be 21a plus 8 equals 50. And now we're going to want to subtract 8 from both sides. (21a equals 42). And I need even more room. Now we divide both sides by 21. We end up with a equals 2. You may want to pause the video and try the last example on your own. D times d is d squared. D times 3 is 3d. And remember, this is like a minus 1d times everything in there. So negative 1d times d is negative 1d squared. And negative 1d times negative 4 is positive 4d. Equals 9d minus 16. I would simplify the left side. D squared plus a negative 1d squared. Well, that's 1d squared plus a negative 1d squared. That's going to disappear. And then we have a positive 3d and a positive 4d. When you add 3d plus 4d, you get 7d equals 9d minus 16. Now we have variables on both sides. I'm going to get rid of this 9d by subtracting 9d from both sides. 7d take away 9d is negative 2d equals negative 16. Now divide both sides by negative 2. d equals positive 8.